Adrian Newey's AMR26 evolution package has been linked to a staggering 2.5-second pace gain, but that number is not confirmed by the source. What is confirmed is still enormous. Aston Martin is preparing a new nose, heavily revised aerodynamic surfaces, a slightly modified rear suspension, and major weight reduction for the Hungarian Grand Prix. Newey says the team expects a large step, but refuses to give exact figures because the simulation tools are not yet fully trusted. That means this upgrade could finally unlock one of the boldest cars of his career, or expose that Aston Martin's entire concept is still fundamentally wrong. And the most important change may not be one visible part. It may be the moment the whole car finally starts working together. Subscribe to the channel. To understand why this upgrade could completely change Aston Martin's season, you first have to understand how far behind the AMR26 really started. Adrian Newey joined Aston Martin in March of 2025. That gave him roughly 10 months to help create an entirely new Formula 1 car under one of the biggest regulation changes the sport has ever seen. 10 months sounds like a long time. In Formula 1, it is almost nothing. Especially when the chassis rules and the power unit rules change at the same time. Newey himself described the schedule as heavily compressed. And the reason is simple. Aston Martin's wind tunnel program started months later than many of its rivals. While other teams were already testing concepts at the beginning of the year, Aston Martin's model did not enter the tunnel until the middle of April. That delay created pressure immediately. Every lost week meant fewer experiments, fewer comparisons, fewer chances to discover that one clever idea did not actually work. Imagine beginning a difficult exam after everyone else has already answered the first page. You may still be capable of finishing, but every decision must be faster. And every mistake becomes more expensive. That was the environment in which Newey created the AMR26. Not slowly, not comfortably, under pressure. And that pressure helps explain why the car arrived looking so different. The unusual nose, the heavily undercut side pods, the high front suspension mounting points, the distinctive treatment around the rear of the car. Almost every major area appeared to challenge what other teams had chosen. But here is what makes the design even more interesting. Newey does not describe it as one revolutionary component. He describes it as a complete system. That is the key. The AMR26 was never supposed to win because of one magical wing. It was supposed to work because every part supported the next. The nose shapes the airflow. The front wing controls where that air travels. The suspension influences both the mechanical behavior and the aerodynamics. The side pods manage the flow toward the rear. The floor creates a huge amount of the car's grip. And the rear suspension helps control how stable that grip remains. Think of an orchestra. One instrument can sound impressive, but if the rest of the musicians are out of time, the entire performance falls apart. That may be the real problem Aston Martin has faced. The ideas are there. The speed is not. At least, not yet. And that is why the reported 2.5-second gain must be treated carefully. The source does not confirm that number. Newey himself did not promise it. He only said Aston Martin expects a large step. And even then, he warned that the team's simulation tools are not yet as accurate or as well connected to the real car as they need to be. That warning changes the meaning of the entire upgrade. Because a large predicted gain inside a computer means nothing if the real car does not respond the same way. This is called correlation. And it may be the most important word in Aston Martin's season. Correlation means the virtual prediction must match reality. If the simulator says a new nose will improve the airflow, the track must confirm it. If the wind tunnel says a new surface creates more downforce, the driver must feel that improvement. If the computer predicts better balance, the lap time must show it. When those three worlds agree, development becomes fast. When they do not, development becomes guesswork. And guesswork is dangerous. A team may spend weeks creating a part that looks perfect inside the simulation. Then Fernando Alonso drives it for 3 laps and immediately feels a weakness the computer never predicted. Now the engineers must decide whether the part is wrong, the setup is wrong, or the simulation itself is misleading them. That can waste an entire race weekend. Sometimes more. This is why Newey refused to attach an exact number to the upgrade. He expects progress. But he does not fully trust the tools yet. That is not weakness. It is honesty. And it reveals how much work Aston Martin still has to do behind the scenes. The new factory is there. The new wind tunnel is there. The new simulator is there. But new equipment does not become perfect on the day it is switched on. It must be calibrated, compared, corrected. Engineers need to learn which results can be trusted, and which need more investigation. That process takes time. And Aston Martin is trying to complete it while racing. That is like building a map while already driving through the city. Every wrong turn teaches you something. But every wrong turn also costs time. The Hungarian Grand Prix upgrade is therefore much more than a collection of new parts. It is a test of the map. Can Aston Martin now predict what the real car will do? Can Newey's new development process finally connect theory to performance? And can the team prove that the radical design has been misunderstood rather than fundamentally mistaken? Those questions create enormous pressure. Because Aston Martin is not sitting near the front. It is near the bottom of the standings. Fernando Alonso has managed only a single point. Lance Stroll has none. That is the brutal reality behind all the excitement. The car looks bold. Experts respect the ideas. Rivals have noticed the design. But the results have been painfully weak. And Formula One does not reward creativity by itself. The stopwatch does not care who designed the car. It does not care how elegant the suspension looks. It does not care whether the side pods are original. It only cares whether the car is fast. That is why Hungary becomes the first true judgment. A new nose. Substantially revised aerodynamic surfaces. A slightly modified rear suspension. And significant weight reduction. Those are not cosmetic changes. They attack several weaknesses at once. The new nose may change how the air reaches the front wing and the floor. The revised surfaces may help the car create more consistent grip. The rear suspension adjustment may improve stability and help the aerodynamics work through a wider range of conditions. And the weight reduction helps almost everywhere. Braking, acceleration, tire stress, direction changes. A lighter car does not solve every problem, but it makes almost every problem slightly easier. Think of running while carrying a heavy backpack. You can still move quickly, but every step costs more energy. Remove the weight, and your body responds more freely. A Formula One car reacts in a similar way. Less weight means the tires have less mass to control. The brakes have less mass to slow. The engine has less mass to accelerate. And the driver can change direction more efficiently. That is why getting closer to the minimum weight limit matters so much. But weight alone will not transform Aston Martin. The aerodynamic package must work. And that is where the new nose becomes especially important. The nose is not just the front of the car. It is the first major decision the airflow encounters. A small change there can influence everything behind it. The front wing, the floor, the side pods, the rear of the car. One small shape can change the path of the air across the entire machine. Imagine placing a stone in a stream. Move it slightly, and the water divides in a completely different way. That is what the new nose may be trying to achieve. Not simply more grip at the front, better airflow everywhere. And that would fit Newey's philosophy perfectly. He is not chasing one spectacular component. He is trying to make the whole system more connected. That is why the front suspension remains unchanged. Aston Martin is not abandoning the foundation. It is adjusting the pieces around it. That suggests Newey still believes the original architecture has potential. The concept may not be wrong. It may simply be unfinished. That difference is enormous. A wrong concept needs to be replaced. An unfinished concept needs to be understood. If Aston Martin finally understands it, the development curve could become much steeper. The team may discover that one improvement unlocks another, then another. The car begins responding more predictably. The drivers gain confidence. And suddenly, what looked like a failed experiment starts becoming a platform. That is the optimistic version. But there is another possibility. The upgrade may arrive, and the stopwatch may barely move. The balance may improve in one corner and become worse in another. The new nose may create more downforce but also more drag. The weight reduction may help, but not enough to overcome the larger weaknesses. And the simulation may once again predict something the track refuses to confirm. If that happens, Aston Martin will face a much deeper problem. Because this is the first major package developed through Newey's new structure. It is the first serious attempt to turn the radical idea into competitive pace. If it fails, the team cannot simply blame the launch specification. The questions will shift toward the tools. The process, the communication, and the entire direction of the car. That is why the upgrade carries so much emotional weight. It is not only about points. It is about belief. Fernando Alonso needs to believe the project is moving forward. Lance Stroll needs a car he can use consistently. The engineers need proof that their work is producing real gains. And Newey needs evidence that the foundations he chose can support the future he imagined. Without that evidence, the bold design becomes a burden. Every unusual feature starts looking suspicious. The high suspension position becomes a compromise. The narrow side pods become an obstacle. The rear packaging becomes too aggressive. And the development potential becomes something everyone talks about, but nobody can see. That is the risk. But there is another problem Newey cannot solve with aerodynamics alone. The Honda power unit. The source reports that it may be around 50 kilowatts behind the strongest engines. That is roughly 67 brake horsepower. If that figure is accurate, it represents a major disadvantage, especially on long straights. Aston Martin can reduce drag. It can improve cornering speed. It can save weight. But it cannot create missing engine power through bodywork alone. That is like trying to win a cycling race with better clothing while your bicycle is stuck in a lower gear. Aerodynamic efficiency helps. It may even hide part of the deficit. But eventually, the straight arrives, and the missing power becomes visible. That may explain why Newey's concept appears so extreme. The car cannot afford to be ordinary. It needs to recover performance wherever possible. The suspension must help manage airflow. The bodywork must remain incredibly efficient. The active wings must switch between cornering grip and reduce drag with precision. The packaging must avoid unnecessary resistance. Every part must do more than one job. That is not simply creative engineering. It may be survival. And this is where the Hungarian upgrade becomes even more important. If the new package reduces drag while increasing usable grip, Aston Martin may hide part of the engine weakness. If it only creates more downforce, the car may become faster in corners but even more vulnerable on straights. The balance between those two outcomes could define the entire upgrade. More grip is good. Efficient grip is much better. That is what Newey has spent his career chasing. Not maximum aerodynamic force at any cost. The right force, in the right place, with the smallest possible penalty. And the new active aerodynamics rules make that challenge even more complicated. The front and rear wings can move between corner mode and straight mode. One setting creates more grip. The other reduces resistance. That sounds simple. But the entire car must remain balanced during the transition. If the front changes too quickly, the rear may feel unstable. If the rear loses too much load, the driver may lose confidence. If the systems do not work together, the car may be fast in theory and difficult in reality. That is why Newey's complete system approach matters so much. The AMR26 cannot rely on one strong area. Everything must switch, respond, and support the driver at the correct moment. And right now, the team has not shown that consistency. The Hungarian package is designed to move closer. But nobody knows how close. Not even Newey is willing to say. That uncertainty is what makes the next phase impossible to ignore. Aston Martin does not need to find 2.5 seconds. That claim is not supported. It does need to find a clear, repeatable step. A car that qualifies better once is not enough. A car that scores because of unusual circumstances is not enough. The upgrade must work across different corners, different fuel loads, different tire conditions, and ideally, for both drivers. That is the true standard. If Alonso improves but Stroll does not, the operating window may still be too narrow. If the car is strong over one lap but weak in the race, the tires may still be suffering. If the car gains speed in Hungary but struggles at the next track, the concept may still depend too heavily on one type of circuit. A genuine breakthrough must travel. That is why the first result will only be the beginning. Hungary will provide the first clue. The races after it will reveal whether the clue was real. And Newey knows that. He is not promising a miracle. He is promising a major attempt. That difference matters. Because miracles disappear. Development is supposed to continue. The best outcome for Aston Martin is not one shocking result. It is a new direction that produces another improvement, then another. A car that finally responds when the engineers ask it to change. A car that gives the drivers confidence. A car that turns radical ideas into reliable speed. That is what this package must begin. And if it does, the AMR26 may become one of the most important comeback stories of the season. Not because it suddenly gains 2.5 seconds. Because it finally proves that the extreme design has somewhere to go. But if the new nose, revised surfaces, weight reduction, and rear suspension changes fail to create that proof, the problem will no longer be the first version of the car. The problem will be whether Aston Martin's most ambitious project was built around potential that only existed inside the simulation.